Okay, good afternoon everybody. Name is Dr. Vadgama and I practice at a private clinic in Kent. My talk this afternoon is high-tech implant placement procedure, is what I call HTIP. Let me just talk to you a little bit about my personal experience and what I've been doing in implants over the last 25 to 30 years. It's a special interest and I've been involved with implant dentistry since 1986. So I've been in the same clinic for 33 years, and in a way it's a good and a bad thing, because all the treatments that I've provided over the years, I always get a feedback and I'm able to assess what sort of treatments are working and which treatments are successful, and my patients are prepared to go ahead with it. So I've placed over 8,000 implants. On average we do 400 plus implants per year, out of which majority are the ankylosing implants, and we also use Straumann implant system in some cases. Have a success rate of 98 to 99%, and by using the high-tech implant placement procedure, I'm going to talk to you how we managed to get the high success rate. So in order to be able to get such a high success rate, we look around to see how we can move from a traditional implant placement to a high-tech implant placement procedure which involved 3D technology. In the past we used to use 2D x-rays, which obviously does not give you enough information, but using the 3D data from different technologies, we were able to now assess each case. So what we did is we invested into a CBCT scanner, Galileo. We have been using the CEREC system for many years, so there was a natural connection between the two, whereby we can take the 3D impressions on our CEREC system and transfer them onto the CBCT scanner, so that we can work backwards to plan where the implants are going to be placed. Furthermore, with the in-lab software that we use on the CBCT on the CEREC Sirona unit, is that we can convert the data into STL file and then transfer it to a 3D printer and then fabricate the surgical guides, duplicate dentures, models, and furthermore, by having the MCXL milling unit, we were also able to mill the abutments and 5 to 6 unit bridge units. And you must not forget the ability to connect the iPad to your system, so that you can hand that to the patient, and the patient can actually look at this data in 3D while you talk to them, and in a roundabout way ethically market this treatment, because at the end of the day we're in business and we need to be able to explain to the patient exactly what we're going to do, and all this combination of technology allows me to do that really efficiently. So the data that we can get from all this 3D scanning technology, 3D CEREC technology, all superimposed, is ability to fabricate surgical guides. We can also do single implant CEREC guides. This can be fabricated and made in the clinic while maybe in a day, and you don't have to wait a long time to have them done. And a lot of the other guides, you got to send it off to a third party to fabricate the guides, which will then take a couple of weeks for them to be delivered to you. Whereas by being able to do the surgical guides in-house, we are able to cut the time between the treatment planning and the placement of the implant. And the data that you can get from the 3D scans, one of the data that we use is the Hounsfield value. What that is basically is the density of the bone. So if the bone is dense, it will be a high value. If the bone is soft, then it will be a low value. And this is a very useful information when you're using one of these Physiomed dispensers with a torque to be able to place your implants, to give you feedback as to what sort of bone you're working with. And then furthermore, you can do cross sections on this and see what the Hounsfield value is around the implant, inside the implant, and within the adjacent bone. So once you have all this 3D data, how do we go about putting it all together and fabricating the surgical guides? What we use is the Galaxis Galileo software, whereby in this case we're doing an upper arch reconstruction. So what we did is we made a patient acrylic temporary bridge and lined it with barium material, which then is able to reflect in the CBCT scan and show you where your prosthetic elements are going to be. And from that data we can now work backwards to see exactly where the implants are going to be, And as you can see, the sleeves that we have placed there are also very, very useful in allowing us to work out as to where the guide of the drill is going to be. So in a cross section, you can see where the implant is going to be, together with your proposed prosthetic abutment tooth or a bridge tooth, and the green is where the sleeve is going to be fabricated in your 3D stent. So once you have this data, you can then convert that into STL format, get on with the 3D printing, fabricate a model, and then on that you can go along using certain software, which I won't go into at this stage, to fabricate your surgical guides. You then place that into the patient's mouth to check to make sure that's fitting. And now you have a system whereby you can use these dedicated kits for guided surgery to start your implant procedure, the high-tech procedure. And with the dedicated guide, you also on the iShiroko implant med unit, you have a sequence of drilling sequence that you're going to do, which now corresponds with the way the instrumentation is laid out in your kit. So the whole process is coordinated between your implant med drill and your implant procedure. So the chances of having any mistakes or looking or fumbling for drills, the right drill, is just very it's just not going to happen, because you're going to follow the sequence and you are going to be able to do step 1, step 2, and get all the data in order to work out as to what the where the implant was placed and what the torque was. So basically, when you put the surgical guide, this is just to show you exactly how we follow the sequence in order to place the implant. And this is an expert ease guide. That is the data we can get from the Galileo Galaxy software. So what you have is you have the bone and the guide placed with a couple of screws if you were to keep it in the right place. Use a tissue punch to just prepare your first part of the surgery, cortical bone to go through the cortex, and then the sequence of files to get it to the right diameter, the right angle, and the right length. Because at the end of the day, for every implant placement procedure, you want 3 things. You want the point of entry, you want to be able to get the right angle for the implant, and the right depth for the implant. So in practice, what happens is you put the surgical guide in the patient's mouth, locate it nice and steady, and then just follow the sequence to prepare your osteotomy sites. And as you can see, we now managed to get this implant in a perfect position as planned on our CBCT scan. So we've been able to take the data from our CBCT scan through a surgical guide, transfer the data into the patient's mouth, and everything that we had planned to make sure that the implant's only going to be a millimeter away from the sinus. We wanted 1 millimeter just subcrestal, and the distance between the implants is all now precisely as per your CBCT scan. Now, before we move to this high-tech technique of placing implants, we used to use handheld instruments, and these are different kits. And if you go around, you'll find lots of companies selling you kits and implant kits. And what basically it is that you have a set of drills which you use a standard physio dispenser to prepare your site. Then after you prepare your implant site by going through the sequence, which basically is the first entry point with the round burr, twist drill, and then sequence till you get the site ready for the placement of the implant fixture, you have to then use, in most of these cases, a torque wrench, which is a handheld technique. So the high-tech technique is to use the implant motor to drive your implants into the site, whereas the handheld technique, which is what we had used for many years, is a good technique. There's nothing wrong with it, but we wanted a lot more feedback and accuracy in able to decide at to what level the implants were going to be placed and what was the torque on the implants and how stable they were. So in doing some research on this, I realized that some of these torque wrenches, even though the manufacturers say that they're very accurate and you can send them back for calibration, after about 10 applications, the spring settings are not as accurate as the manufacturers claim to be. And that can have a profound effect on the amount of torque that you're going to place on your implants, because then you could be placing a lot more torque or a lot less torque, and that will have an effect on the bone physiology and whether you're going to put so much stress on the osteocytes that you could probably get bone necrosis. So looking at the whole concept of using the mechanical implant procedures, looked at the various systems and how they're used. And one of the things that caught my attention was the endodontic guys. They're really ahead of us in terms of using their the drills to be able to prepare the root canal sites. So if you look at majority of the endodontists, you'll find that most of them use rotary instruments to prepare. No, you don't find many using hand instruments these days. Whereas with the implant dentistry, a lot of the implant dentists are still using the handheld instruments at the end and haven't actually moved to using the mechanical high-tech method whereby they can control the torque and be able to get a feedback as to how you're placing the implants. So gradually, I think this is the way things are going to go, and as time goes, I'm sure that more and more implant dentists, by using the technology we have, is going to move nearer towards what the endodontists are doing. So we got some catching up to do. And the reason why we like to use one of these physio dispensers is that all the research shows that for immediate loading, 35 NCM is a good torque, which means the bone is being treated gently and allows you to get the confidence level in order to load those implants immediately. So if your site is over-prepared or you're using a very soft bone, then the integration is not as good. Whereas if you really torque the implant and put a lot of pressure on the implants and just take the torque wrench and really drive it in, you might get the implant into your site, but the amount of torque that you place will probably cause necrosis of that implant, and hence your failure rates will increase. So the only way to be able to assess this torque and the ability to get the confidence to place these implants was to use one of these PhysioMed dispensers. So basically, we moved from a standard drill to one of these high-tech units, which are dedicated and designed from ground up, in which you can control a lot of parameters: the amount of saline flow, the speed of the drill, and the illumination is very good with the LED lights on it, so you can really see the field that you're working on. We then introduced this iShiropo implant med about 18 months ago. So the last 800 implants out of the 8,000 that I've done, I've more or less used exclusively the implant med unit to place and drive the implants. So basically now we got, for this high-tech implant placement procedure, all the synergistic benefits of having your CBCT scan, 3D scans, being able to use your CEREC unit to design and plan your surgical guides. You can integrate all the 3D scans, fabricate your surgical stents, but at the end of the day, all these procedures are done when the patient is not there, because you've collected the data, you get the patient to go away, and then you're going to do the treatment planning, probably write to them. So you've got plenty of time to do that. But the tricky bit is when the patient is in a chair. And there's a limit to how long you can keep a patient in a chair, because the longer you keep them, more frigidity they get. And if you can do the implant procedure swiftly and silky smooth by using one of these implant bed units, then you're going to do a patient a really good service. So when I wanted to upgrade the implant unit, I was also thinking of upgrading my car, and I looked at the magazine and the internet, and I came across this ad, and the thing that caught my attention was this 700 NCM. So it's a nice slick machine, right? German precision engineering, and you all like to have one, right? But maybe not, maybe yes, but at the end of the day, it's a powerful machine with a lot of torque, and if you buy one of these, you're going to have to be able to learn to drive it, because otherwise you will have a little difficulty in controlling this this motor. In a similar way, an iShiropo is a baby Porsche, basically. It costs about 3,000 to 4,000 pounds, whereas a Porsche is going to cost you about 70,000. But the important thing here is the ability to control the torque, and then you got all the different features on that, which allows you to plan your implant case on the day. The important thing here is the 70 NCM, which is the maximum torque, as you can see on the implant bed unit on the big screen there. It's about 100 pounds per square inch. So how do we use all this high-tech data in our day-to-day clinical practice? Because you got all your arm to your back teeth, you got all this investment you made of a couple of £100,000 to get all these bits in, and the way I'll just explain this to you is by looking at some simple cases. And one of the things that's very popular these days is planning an all-on-4 implant case. Basically what we're doing here is we are placing the implants and then loading them and giving the patients teeth on the same day. And that's a popular treatment, and all the research is showing that if done in a proper way, the success rate and the patient satisfaction is very high in this type of procedures. So what I've got here is a CBCT scan was done. I've decided where the implants have to go. These are my sleeves through which I'm going to use the iShiropor unit to place my implants, and I've got a cross section, tells me where the ID nerve is, shows me the cortical bone, and generally I've got a lot of information there to be able to plan my surgical guide. And in order to plan your surgical guide, what we do is on the software, it's a built-in process. You don't need to have a lot of training to do this. You select your implants, click next, and then it gives you this set of steps that you can follow in order to either order your surgical guide or maybe make it in-house. So in this case we're using 4 ankylosing implants, 9.5 length, and as you can see, the patient was in the chair, pop the surgical guide in without any flaps. You're prepared to prepare the 4 sites and be able to torque them up to 35 NCM using the implant med unit. Now why it's important for immediate loading for me to know and have the confidence that I want to immediately load these implants on the day, that's because if you look at 35 NCM and look back at one of the slides which said that 70 NCM is 100 pounds per square inch, then that tells you that each implant is going to be up to 50 pounds per square inch. Now if you put the 4 implants together, that's going to give you 200 pounds per square inch of stability. For a normal human being, the amount of occlusal stress or the biting pressure that one can place is around 200 pounds per square inch. So now you have a scientific basis to work and to justify and to give you the confidence, yes, I can load that 4 implants on the day. So if you didn't have the right torque, you wouldn't load those implants and you would leave them submerged and come back in 4 to 6 months and complete your case. In a similar way, you can plan your single implant case. Same thing again, you take your CBCT scan, get your data on your Select 3D, transfer it to the scan, fabricate your surgical guide from the data that you have. And in the same way, a flapless surgery, place the implant, you know the torque is 37 NCM, so you got the confidence to load that implant. That would be about 60 pounds per square inch. So this immediate loading on single teeth, it's a myth. Normally, most people, I think, will place the implant and keep it out of occlusion. As you can see, when we fabricated the CEREC temporary crown from material called TelioCAD, we kept it out of occlusion by about 0.5 millimeter. So that when the patient bites into centric occlusion, we want to make sure that there is not that much stress on the implants, because if you load those implants on the day, there's a very high chance that those implants are going to fail. The research shows that if you load them on the day on single implants, you'll have a much higher failure rate. Similarly, you could do multiple implants, and in this what we have done is we're placing implants in the lower mandible bilaterally, 3 implants, but in this instance what we wanted to do was to also fabricate the ceramic abutments on the day, so that we could actually screw them in and put the temporary teeth for loading on the same day. So you had the surgical guide, the planning was done, followed it with the surgical sequence by using the implant med unit, and then place your implants. And obviously the whole process is very slick because you follow the steps on the implant placement by using the PhysioMed motor, and you can complete one of these cases in maybe half an hour or 45 minutes. So from a patient's point of view, it's a lot more comfortable procedure, plus you don't have to do flaps as well. So let me just summarize the benefits of using HTIP method, which is what I call high-tech implant placement method, is that from a dentist point of view, your benefits are that is less complex, you don't have to do a lot of GBR, and at the end of the day, from a patient's point of view, it's less operative trauma, less expensive, because the procedures you've done are much simpler, faster healing, you're not raising a flap, and compromising the blood supply to the cortical plate. As you know, the periostral membrane supplies the cortical plate, and again there's a less post-operative discomfort. So it's a win-win situation for you and your patient. One other thing that I just want to talk to you about briefly is the concept of reverse torque. This is something I've been doing on the last 800 implants that I've placed, and exclusively we placed them by using the iShiroko implant bed unit. The principle behind this is that if the implant is well integrated, then when you put 25 newtons a centimeter torque to reverse it to see if the implant will unscrew, if it's well integrated and very stable, it won't move. Also, if you look at the other techniques that you have, like using the Ostel, the radio frequency resonance unit, to measure the stability of the implant, what we found is once or twice we carried out a test with the Ostel, and it was giving a very good reading for a good confidence in that we can load the implant immediately. But when we placed the reverse torque on it, the implant popped out. So at the end of the day, I'd rather have the implant fail while the patient is in the chair than try and load something that I don't think is integrated or is stable enough, and then get the patient to come back in maybe a year or 2 years and see that the implants failed. And there could be many reasons. So if that happens, start again. And that's much cheaper in long run to start again at that particular step rather than loading the implant, making the abutment, loading it up with a crown, and then get the patient to come back. Patients will be quite happy for you to explain to them by using this technology as to why it's not worked, and they'll think you really care for them, because now you've given them a scientific basis as to why this implant has to be taken out, and I'm going to put a slightly larger one and leave it and see if the torque is right on it, and do your test on it to see whether you got the confidence to load the implant on the same day. So to summarize, high-tech implant placement procedure means that you need to use a lot of take all the 3D scanning data that you have, 3D CBCT scans, surgical guides, and then using a high-tech implant made unit to place your implants and get the right torque and the right stability. Now I'm just going to talk a little bit about the iShiroko, and this is something you can talk to the reps here, and they're very good. A lot of them have worked for the Porsche company before. They moved as salesmen for the implant company. So it's a good unit in that it's got control by an iPad. And then it's got all the other features in there. The MXI LED micromotor is your baby Porsche, and that gives you all the control. You can select a lot of different steps, as I said. You can, it gives you the sequence of 1 to 8, and these are the steps that you'd follow when you're placing your implants. Also, you can record all the data of the procedure that you're doing in real time, so that you can print it out and send it to your referring dentist or yourself. Keep it as from a medical legal point of view. It's an important bit of data that you can fall back on if there's a problem with the implant down the line, or if the referring dentist wants to know exactly how well the surgical procedure had gone while the patient was referred to you. Furthermore, you can get all the different graphics and the tables, and again, if you play with these units here, you'll be able to flick through on the iPad screen and be quite impressed with how slick and this product is. Again, having an app for this program, you can actually download the app from the App Store, and you'll have the latest upgrade in the software immediately to use, and you don't have to wait or get a CD from a manufacturer. This is all done online on the internet. So on the whole, it's an amazing unit, and combining that with all the other technologies that we have in the clinic, I can truly say that the high-tech implant placement procedure nowadays has become quite easy. Anybody who makes the necessary investment and spends enough time to train should be able to place implants, single or multiple, and have a lot of confidence being able to do that. You can see it's a really nice, slick looking unit. And with that, let me thank you all for your attention and listening to what I had to say. Thank you very much.
Thank you.